and welcome to UGC NET with Megha. In the previous video of number systems, we have seen the conversion for decimal to various other number systems and vice versa. Now we are going to look up at the other types of conversions, and the very first conversion that we are going to understand here is from octal number system to binary number system. So before actually going into the conversion part, we need to understand the few basics. The base for octal number system is 8 and the base for binary number system is 2. So now this base for octal number system can be represented in terms of 2 raised to power something. Yes, we can do that because 2 raised to power 3 is equivalent to 8. So we can represent it as 2 cube. So basically octal has a base of 2 cube. So now what we need to do is the 8 digits that are there in the octal number system are to be written in 3-bit format. That means the 3-digit binary number has to be written for each of the digits of octal number system. And how we are going to do it, we'll be making a table for that. We'll be considering the values of 2 raised to power less than 3. That means the values for 2 raised to power 0, 2 raised to power 1 and 2 raised to power 2 would be considered, and thus we will be forming a table out of it. So 0 in binary is always 0. 1 in binary is 1. Or you can understand it like that also, that 2 raised to power 0 is equivalent to 1. So we will consider this power and write 1 here, and the other powers which we have not used, for those powers we will be putting 0. Now next digit is 2. So we need the final answer as equivalent to 2. So we will be using 2 raised to power 1 because 2 raised to power 1 is 2. So for that power we will be writing 1 here, and for the other 2 powers which we have not utilized we will be writing 0. In the similar manner for 3 also, for 3 we need these 2 powers, that is 2 raised to power 0 and 2 raised to power 1, that would give us a sum total of 3. So for these 2 powers we will be writing 1 each, and the power which we have not used, for that we will be writing 0. Now for the next digit, that is 4. So we need sum total of 4, that is 2 raised to power 2 is 4. So we will simply use this power and the other 2 powers will not be used. So for this power we will write 1, and for the other non-used powers 0. Now coming to number 5. So now we need a sum total of 5. So we will be using this power, that is 2 raised to power 2 and 2 raised to power 0, because the sum total of these 2 powers would give us 5, and this power will not be utilized. So for this we will be writing 0. So that would give us 1, 0, 1. Now next digit is 6. So we need a sum total of 6. So for that we will be using these 2 powers, 2 raised to power 2 and 2 raised to power 1, and this would be the unused power. So we will write 1, 1, 0. And for 7 we will be using all these 3 powers because the sum total here is 7. So that would be 111, as there is no unused power here. So now this conversion we are going to use in order to convert a number given in the octal number system to binary number system. So now let's take the example, like you are given 2 to 1 in octal number system, and how would you convert it to binary number system. So now you will be considering these 3 digits separately here, 2 to 1, and now we are going to substitute the values of 2 to 1 from this table in the binary digits. So from binary digits, for 2 the value is 0, 1, 0, again 0, 1, 0, and this would be 0, 0, 1. So this entire thing taken together would be its binary conversion. One thing to note here is that if you are given a decimal number system, then how you are going to convert it into binary. So decimal, as in the decimal is placed after 2 digits, not the base decimal. So if the number is like this, 26.28, then you will simply place the decimal in the same position, that is after 2 digits, and then you will substitute the values for individual digits in the binary number system, and you will get the answer for the decimal value. Now we are going to understand how to convert a binary number system into octal number system. It is the most simplest form of conversion. You need to just create group, and the groups will be of 3 digits combined together, and the grouping would start from the extreme right and then we'll be moving towards the left. So if suppose you were given this very number only for conversion, then you would group these 3 numbers together, then these 3 numbers together, and then these 3 numbers together. So particularly you have started from the very right and you have moved towards left. So now for these 3 digits you need to see from the table that which number it represents, and you would be substituting it with that octal number. So this is for 8, this is for 2, and this also is for 2. So in octal base it is 221. Now one more thing that we are going to understand here in this very number system only, if you are given a binary number after the decimal also, then the grouping would be starting from the extreme left and then you would be moving in the right hand direction. That means opposite to what we had done before decimal, it would be totally opposite to that, and we will be moving from left to right while grouping in the groups of 3 digits. The next conversion that we are going to look at is a hexadecimal to binary. So it would be almost similar to what we have done in octal. The only difference is the power difference. Let's understand this first. So we know that the base for the hexadecimal is 16 and base for binary is 2. Now this 16 can be represented in terms of 2 raised to power. So we can represent it as 2 raised to power 4. This would be the base for hexadecimal and this is binary. So now they are in the equivalent base. So now we would be considering the powers which are less than 4. So 2 raised to power 3, 2 raised to power 2, 2 raised to power 1 and 2 raised to power 0. So the values for these are 8, 4, 2, 1. Now again we would be using the combination of these numbers itself to bring the total of all the digits, that is the 16 digits right from 0 to 15 under the hexadecimal, and the digits which we are using to get the total, we will be assigning them as the values 1, and the unused powers again would be assigned the value 0 in the same manner as we have done in octal number system. The only difference here is that we would be taking 4-digit binary number here instead of a 3-digit binary number, and the calculation part would go on till the number 15 instead of number 7. So now we'll understand this. Again 0 would be represented as 0, 0. 1 is in binary also 0, 0, 1. Now for 2 what we are going to do is, for 2 we need this power only. So here we'll assign 1, rest all the unused powers are 0. Now again for 3 we need these 2, so we'll assign 1 and 1 here. The unused powers would again be 0, and in the similar manner we'll be calculating for all the numbers. Like if you talk about 14, so we need a sum total of 14. So we will be looking at 8 plus 4, 12, 12 plus 2, 14. So these 3 powers would be utilized, and this is the power which would be unused. So for this power we will be writing 0, the unused power, and all the used powers would be represented by 1. So this is the binary conversion for 14. So in this manner you can convert all the digits from right from 0 to 15 in binary, and then you can convert the same. Now what you have to do is, like if you are given a number as F16. So we already know that in a hexadecimal number system, F represents number 15. So 15 and 6. So it is 156 actually. So now what you have to see is the conversion for this number 15 and the conversion for number 6. You will be considering these digits as separately. 15 would be considered as one digit and 6 would be considered as another digit, and then you would be substituting it with its binary equivalent. So for 15 we need all these numbers taken together. So all the powers are utilized. This means 4 times 1 would be representing 15 in octal number system, and for 6 the powers would be utilized would be these 2. The others are the unused powers, so the value would be 0, 1, 1, 0. So this is the binary conversion for F6 or 156. Now we are going to understand one thing, that if we are given any digits after decimal, then it would be converted in the same manner as we have understood in the octal number system. Now, if you are asked to convert a binary digit into hexadecimal number system, so here you simply need to do grouping in for terms of 4 digits, and the grouping would start from the extreme right and move towards the left. So in the same manner, we will group here for 4 digits and then 4 digits, and then we will be substituting their hexadecimal equivalent from the table, and we will come to the answer of binary to hexadecimal conversion. So this we already know is for 6, and this is representing 15. Now 15 is written as alphabet F, so F6 is the final answer of the conversion. And also you need to understand one more thing. If decimal is given, then for conversion the grouping would start from the extreme left to right after the decimal. The next type of conversion that we are going to understand is from octal to hexadecimal. So for conversion from octal to hexadecimal, what we are going to do is we are going to use the same table that we have been using for octal to binary. So we will convert the octal number first into binary, and that binary number will be grouped in terms of 4 digits, and then the hexadecimal equivalents for those 4 digits would be substituted, and thus we will get the answer for hexadecimal conversion. We will understand this with the help of an example. Let's take a number 227. And now we all know the conversions for the power 2 to power 1 and 2 to the power 0 in base octal. So 0 is 0, 0, 0, 1 is 0, 0, 1, and 2 would be represented by 0, 1, 0, and so on. So now we will be using these groupings only, and now since we want 7, so 7 would be 2 raised to power 2, that is 4 plus 2 plus 1 is 7. So all the numbers would be assigned the value 1 because we are using all the powers. So now for 2 to 7 the binary conversion is 0, 1, 0. For this 2 also 0, 1, 0. Again for 7 it would be 1, 1. So this is the binary conversion for the digit 227. Now what we are going to do is we are going to group them in terms of 4 digits. That is, a group of 4 digits will be formed, and we will start from the extreme right position and then move towards the left. So these 4 will be grouped together. These 4, that is 1, 0, 0, 1 would be together, and since the digit that we are left with is 0, so we will be ignoring it. But had it been 1 in place of 0, so we would have to add extra 3 zeros, because no matter what we can add as many zeros before, that is on the left hand side, it would not change the value. So we would add 3 zeros here and we'll form a group of 4 again if the number here would have been 1. But since it is 0, so we can simply ignore it, and we have to look for the conversions of these two numbers in terms of hexadecimal table. So now we are going to refer the hexadecimal table that we have formed and understood in the previous conversion. So here 0111 is again represented by 7 itself. So this number would be 7 only in hexadecimal also, and 101, that means the power of 2 raised to power 3 and 2 raised to power 0 has been used. So this is 8 and plus 1, that is 9. So here the number would be 9. So the number in hexadecimal is 97. Now if there were some decimal numbers also given, then you would be grouping from the extreme left to right as we have done in the previous number systems as well. So the last conversion that we are going to understand here is from hexadecimal to octal. So we are going to use the same process as we have done here. The only difference would be now the grouping would be done for 3 digits together. So we'll convert the hexadecimal digit, let's take 97 only, into binary first, and then the binary equivalent would be grouped in 3 digits, and then we would be looking for the octal equivalent for the group of those 3 digits. So for 9 the binary equivalent is 1001, and for 7 it is 0111. So this is the binary equivalent as we have already seen here, and then we are going to start from the extreme right and group them in 3. And since we are not left with the extra 0 or the third digit, so we'll add a 0 here, and this would again become a padded or the balanced group of 3 digits. Now we'll look for their octal equivalent. So 111 is again 7 in terms of octal equivalent also. 010, that means we have used 2 to the power 1, so it represents the digit 2. And here also we have 010, so it would also represent the digit 2. So this is the conversion in octal number system. Now if you are given some digits after the decimal also, so you will group in terms of 3 only, but the grouping would start from the extreme left and then you will move towards the right hand side. So this is all for this video, and this is how you are going to undertake all the different types of conversion. So basically the conversion that we have learned today, this table is the most important thing that you need to remember. If it is octal as the base, then you need to have a 3-bit conversion table system, and if it is hexadecimal, then the table would be for the 4-bit conversion system, and then accordingly the grouping would be done, that is in terms of 3 digits or in terms of 4 digits. Thank you for watching this video, and don't forget to like, share and subscribe. And if you want me to cover any particular topic, leave your comments in the comment section. For further details on our online course, visit our website www.ugcnetwithmegha.com. The link for the website is given in the description below, and for regular updates, follow us on our social media handles.